we are back up and running again. So let me just find my stream and then we can carry on with the code then. Right. Don't know what it's saying, coding for beginners with Tinkercad. That's not what we're doing. Let me just find that and share that. Okay. There we go. How do we share that? Okay, nearly there. Be 1 second. I just need to share this with the other group. It's never very easy to do this on here. There should be an easier way. There I am. There's me. Where's my stream? Okay, I think people are finding the stream again. Sorry about that, I don't know what on earth happened there. I had to literally unplug from the port on the router that I'm using and plug into a different port. Anyways, let us get back to where we were. Okay, let me just pull up that. So we were literally just about to get into the interesting bit of the code there. And so we've literally just created the transition code there in our transition class, and over in our PicoCat we need to bring that in. So if I go up to the very top there, we can then include here from transition import, and we're calling it transition. There we go. Okay, so we want to create some extra classes now, and Rob's saying hey. Hey Rob, how you doing? Just had a bit of a disaster then. For some reason my internet cut out midstream, which I'd scheduled on Restream. So all the announcements and everything like that people get that the stream's happening, that all kind of goes out the window when using something like Restream. So yeah, that's a bit of a bummer. But these things happen. We can always pick it up, and these things are being recorded, so I can always just mash the two files together and upload it to YouTube later. That's not a problem. Okay, so what we need to do now is we have this servo class, and we're going to have to expand out a little bit what's on there, because we need to have some extra things in it. So let me just pull up the code that I need to have. So I go into that one there. Right. So what I'm going to do before we do the servo class, I'm going to create a new class within this file that I'm just going to call limbs. And this is going to help us remember kind of what pin things are connected to, and also what we're actually calling them, because it'll be an easy way for us to bring this up. So front left leg, and we're just going to have that as 0. And what I mean by that is on our robot, the front left leg is this limb here. So it's the main limb, not the foot, not this foot, but this limb here. So that motor there, that servo, where the wire is that's coming out there, if I follow that through, that will plug into the very first pin on this this PCA 9685 board there. So this is kind of what we're representing in this code here. So front left leg, front right leg is next. And then we're going to have the back left, oops, we can type leg, and back right leg. A bit tedious this, but you can get the idea. And then we need to do the same thing but with feet. So let's just grab all that, oops, and paste it in. And then let's just change that last thing from leg to foot. Okay, so we can just do that. And then we can go 4, 5, 6, 7. And then we need the tail, so let's put that on as well. Tail is 8. Hey Tom, I'm glad you found the stream again. Yeah, I had a bit of an issue there with the router, I think it was. Oh well, the network switch. For some reason it wasn't recognising the thing was plugged in, and I think it was actually going out over Wi-Fi, which is really flaky in here anyway, so I've just had to unplug it and plug it back in again. Very technical, and we're working again. So, and then head. Okay, so this is going to represent all the different limbs, basically all the different servos that we have. I'm just going to close this little window here because we don't need to see that the Pico is on board. We can see that it's plugged in there, which is good. Okay, so that's the limbs. And that's going to help. Let's just do a little comment. One of the things that's really useful to do with Python is when you define like a class or a function, if you use this triple speech marks, it will put it in, particularly in VS Code, it will put it as like a code tooltip so that you can see what this thing is. So I'm going to say set up legs and feet to correspond to the correct, it calls them channels in the PCA 9685 board. So we have 16 channels to go at. Cool, so that's that. So then further down then, let's get rid of some of them extra spaces. We only need 2. And then here where we've got we've not used max and min, we will have to use that just for some error checking in our code later on, but we'll leave that off for now. And what we need to also include is these things that we need to make the transitions work. So we need to know what the current angle is. And we have Sammy saying hi. Hi Sammy. Samo, how are you doing? And current angle equal. We're going to just set a default value to like 90 degrees. We're going to set a transition type. And I'm just going to make that a text string so that we can remember what that is. So I'm going to call that ease in sign. We're going to have duration, which I'm going to just default to ½ second. And I'm going to store that duration. That's a good point. I'm going to store that as, let's just make a note of that. This is in seconds because that might be incorrect. It just needs a value to begin with. Channel is kind of like the pin number that we're on, so I'm just going to set that to 0 to begin with. And we might use this servo to represent individual servos, or we might represent servos that are connected to, you know, one of these PCA boards that need a pin number and or channel. So we're using kind of both options there in here. We've got the min and max angle. We're then going to have a target angle, and that's what we want the thing to move to. So for the target angle, I'm just going to set that to 0 as well for now. Then we're going to have the current time, and I'm going to set that to 0 to begin with. And remember these double underscores, I was reading about these yesterday. In C and C++, you have this idea of like private and public functions in a class. And this is kind of the closest thing that we have to this in Python. A lot of people use this, like myself, to represent it's a private class. It's not something you should tinker with from outside looking at these things. But Python actually doesn't hide anything like that. It actually just substitutes. What it actually does is puts the word servo like that in front of it to try and protect the namespace. But from my point of view, I like to do this just to say, don't use this value, use the nice property instead. So changing values next. If you remember, that's one of the 4 parameters that we need. Target angle. We've already got target angle, so that's fine. And tick. Let's just have some other ones. So we'll come to what ticks are in a minute, but tick started equals false. And tick start time equals 0. So these ones here are all used for the easing. Okay, let's get down a bit further to see what we need to do next. So in the fuller version of the code that I've got in the OpenCat.py file, I will actually create for each of these things a getter and a setter, a property and a setter. But for the purpose of this code, we can just sort of cheat. So let me just find what we really need to do, which is the tick. Right. So how this code is going to work is we need to have a loop in the main PicoCat thing. And when we call a function such as stand up, what we really need it to do is to tick some of the function for as long as that tick returns a false value. When it says true, we're going to stop ticking it. And that will enable us to have many different servos all doing different functions at the same time seamlessly. So we don't have to wait for a leg to sort of nicely move and then the other one nicely move. We can have them all working at the same time, and we can have that by essentially just setting kind of tiny fractions of movement for each of the things that we're interested in. And we do that through what I call a tick. So let's define tick in here. So we just need a self in there. And I don't think we need anything else. So the first thing we're going to do in the tick, if you remember from that code that we showed just before, we're going to set the current time to, and then it's ticks US. Now we haven't imported the time function, so what we need to do is go back up here where we've got sleep. We also need to include ticks US, I think it is. There we go. Okay, let's go back down to our tick, which is, where's that disappeared to? There we go. Okay, so once we've grabbed the current time, and that's just a really long number of how many seconds since the Pico board was booted up, we're then going to say the elapsed time equals self.elapsed time. So and if the elapsed time equals is greater or equal to the duration, then we can say stop, return true. Otherwise, carry on. So what we then need to do is we need to say the current angle equals self.current angle, just to give it a value to whatever the current value is. And then, so I've got a load of different if statements next, which is for each of the different types of transition that we've passed in. So I'm not going to type all them out here, but suffice to say we have a similar kind of block that says if the transition is equal to ease in sine, which is the one we're interested in, then do this. So we say current angle equals transition, and that's the name of the class that we created before that we brought in, which is in here. So the class is there, and then the dot will then give us the function that we're after. So if we then say transition dot, and then there it is in the auto fill in, so we can say ease in sine, and then we need to pass it those four things. And can you see there what's really nice about this? It gives us, I just move over to that side there, it gives us those four parameters: current time, start time, change in value, and duration. So it's really nice that it kind of helps us out like that. Okay, let me just put me back over there for a second. So what we need to then do is we need to say current time equals, and it's the self dot elapsed time. Why not created a elapsed time? So we've got elapsed, self.elapsed time. What we'll probably have to do on here is just create an elapsed time variable. Let's just do that 0 for now. So elapsed time equals elapsed time, the current time there. Okay, and the next thing we need to have in there is the start value, and that's going to be the self.start value. Now if you remember, that was actually a calculation, so what I'm going to do here, I'm just going to make my code a bit easier to read by putting that underneath here. so that they're sort of in alignment. It does complain about line lengths if you don't do that. So if you remember, this was the is it just the start value? Is it the changing value? It's the changing value that's the one. So this is nice and easy. So this is just self.start value. The next one is the changing value. So that is the start value minus the target value. So let's do that self. No, let's do. I'm just trying to think where we stored that in there. So we have the target angle and we have the current angle. So I think it's start value minus self dot target angle. I think that's correct. And then we have the duration, which is nice and easy. Okay, and the reason we're using self in all of these different things is because we're going to set them before we run the transition. We're going to set all the different for parameters, and then we're going to say do this. So that's why we need to pass them in. And once we've passed them in, we've now got the current angle. So then all we need to do then is do self angle and then set it. So self angle equals, because self angle there will set the actual servo. There's the line that sets the servo to be whatever we need it to be. So self angle equals, and then current angle. Now what I'm going to do is I'm going to put that inside an int function just to make sure we don't have floating points. These servos are not that accurate, so giving it like 0.3 of a degree isn't going to make much difference, particularly that we're moving this over time. So that's why I'm just putting an int. It'll just mean the thing works properly. And that's all we need to do there. So that tick there will come along, it'll grab the current time, it'll check if the elapsed time is the same, is greater or equal to the duration. If it is, at that point stop, don't do any more ticks, otherwise carry on. And it will only return true at that point, otherwise it'll just carry on doing these transitions and setting the angle. So another thing that we need to do then is we need to create a leg class. So let's do this underneath all of this stuff here. Let's do it just down here. And our leg class is going to represent each of the 4 legs. So we're going to give it a name. Let's just call it leg for now. And we're going to have an initialization function. Just need self in there. And we want to be able to pass this a couple of pin numbers. So shoulder pin, oops, and foot pin. And we can also say name, but that's optional, so we can say that's none. And excuse me, in here we can say self shoulder equals servo, and let's just pass in those things that have just been given. So the name is equal to shoulder, the pin equals shoulder pin that's been passed in, and we'll have another one which we'll call foot, and that's going to be servo name equals foot, and the pin is going to be equal to foot pin. And then if the name that's been passed in is not none, then self.name equals name. So that's what our initialization is going to do. It's pretty straightforward. And let's give it a function where it can actually do something. So we're going to make it stand up. So when the cat says stand up, all 4 limbs need to sort of stretch out into a position. Probably all the servos are at 90 degrees would be my guess. That might be correct, that might not be, but let's go ahead and assume that's correct. So let's just print something out to the terminal that says standing, oops, sorry, just jumped right across that, standing up leg, and then we'll just do a comma and then we'll do self.name just so that it can say standing up shoulder, standing up foot, that kind of thing, or left leg, right leg. So then we're going to say self shoulder dot transition, and this is going to be equal to ease in sign, which is the only one that we currently have working. Let's do the same for the foot. Transition equals ease in sign. And what I've done in my other code, just for interest, where I've got that double underscore, I've created a property instead on the OpenCat, and it will check to see if the value that's being passed in is actually a valid transition type. So it has like a dictionary of all the different types of transition that you can have, and it just checks to see if the string that's being passed in is inside one of those, inside that dictionary. It's one of those types that's valid. So that's where properties are better than setting things directly. Okay, so let's just add some other things. So we've got quite a few things to set here, so let's just leave a line. So we're going to say self dot shoulder duration. So let's do shoulder dot duration equals, now let's go back to, it might be worth creating a little function that can help us here, because rather than setting the duration in microseconds and having to figure out what that is, it'd be really easy if we could just set that in seconds and have some code behind the scene that just multiplies it by 1,000,000. So let's do that. So this is in the servo code. So let's scroll up to the servo, past the initialization, and let's just create a function that's called, and it's going to be, it's not going to be a property, yeah, it's going to be a property. So let's do property, and we'll call this one duration in seconds. So it's needed self, and what we're going to do there is just return self.duration and then multiply that by 1,000,000. So that should be, yeah, 6 zeros. That's all that's going to do. And it'd be really good if we just put a little reminder in there that says returns the duration in microseconds. Okay. So that means that we can actually see what that is as a value, and we probably need a setter as well. So let's just do another duration in seconds. It has to be the same name as the one above. If I can type, and we just need a value. And we just need to say dot setter. There we go. Oops. And this is that's there. Okay, and then what we want to do is just set the duration. So self dot duration equals the value times by 1,000,000. Okay. So then further back down in our standing code that we've created in our leg, we can now say set duration in seconds to equal, let's say 2 seconds, and that will figure out that that's 2,000,000 microseconds, blah blah blah. So that makes that much easier to manage. We could also do some error checking in that code further up in the servo class to make sure it's a valid, it's not a negative number and stuff like that. Okay, so that's standing up, so that's the duration in seconds. Then we need to do the target angle, so self.shoulder.target angle, and we're going to set that to 180 degrees. We're going to set the start angle, self.shoulder.start value equals, let's say 90 degrees, just to make it a bit more interesting. And then the change in value, self.shoulder.change in value is going to be self.shoulder.target angle minus self.shoulder dot start angle, start value. And we can do that with the foot ones as well. I'll leave the foot ones out for now. We'll just do the shoulder, but essentially we can just do all those same things we've just done there, just rename that to foot. And then we need to start some counters. So let's do self.shoulder.tick start. Now, I'm not sure we've written that yet, so we need to come back to what that means, I think. And then let's do the same, self shoulder or foot tick start. And let's go and add that to our servo class. Let me just find that one there. And it's a really simple one-liner. So let's go back up to the top of our servo thing, and where we've got tick, let's just above that do tick start. So tick start. And all this will do, just grab the time and stick it in the current time, so in the start time, sorry. Start time equals tick US, like so. So that's just going to grab that start time, put it in a variable, and we can then use it to figure out where we are in time based on that. Okay, so is there anything else we need to do in there, in the standing up code? So then we need, is that the best place to do that? So what we need to do now is have, actually I'm going to put in here, this is the wrong place to put this code, but we're going to do it just because we just need to understand what's going on. So in our standing up code, and I'll explain why we shouldn't have it here, I'm also going to put a little loop. And what I'm saying here is, while the self.shoulder elapsed time is less than equal to the duration, oops, shoulder duration, and where we've got elapsed time, it would again be great if we have elapsed time in seconds as well as duration in seconds. So we'll come back to that in 1 second. We'll correct that because I think it'll just make the code easier to read. And then all we're going to do is just say shoulder tick and oops, and the foot tick. I'll tell you why this is the wrong place to do this. So let's just go and tidy up that. So elapsed time in seconds, so that's back in our servo code up here. So where we've got duration in seconds, let's just do another one similar to that, which is a property which is elapsed time in seconds. And this is just going to return self dot let me just find that. I'm pretty sure I know what that is. Elapsed time in seconds. There we go. So elapsed time is the current time minus the start time. Current time minus self dot tick start time. So do we have, I don't think we have elapsed time as a property. Okay, that's fine, that's fine. So we can do that, and then for the other one, which is the setter, which is going to be elapsed time in seconds, dot setter. And then we just need to do the same name again, but have a value passed in. and then we simply say so it's going to be setting it this time. So that's going to return it divided by 1,000,000, and this one is going to set it, so self dot elapsed time times by that. And then just so that we can remind ourselves what this is, let's just put some code in there. So this is returns the elapsed time in seconds. And this one, oops, that's the wrong place. Just lost my place now. So that one is just there, and this one will set. Can we set the elapsed time there though? I'm not sure we need that one. I think that one is implicit. I think we just need to get it. Okay. So then further down in our code here, where we have duration, and what we want to do there is just say elapsed time in seconds, and then duration in seconds. Just makes it easier because we're looking at the same thing. So we're going to say while it's less than the amount of time that we've allocated, the 2 seconds, keep ticking, and the ticking is going to, that's within the servo code if you remember, and that's just going to set the angle using whatever transition type we've got. Cool. Now the reason I think that's in the wrong place there is that loop shouldn't be within the leg function, because that's going to block. That's going to mean that we can't set 4 legs to all work at the same time, because it's going to come down to this point and it's going to run this code until that's finished, until that condition is true, then it's going to drop out and then it'll run to the next leg. So that really should be in our PicoCat, which we haven't even created yet. So the last bit of code, just aware of time, we'll create a class for our PicoCat, and that's quite a simple one. So let's just do class PicoCat. And let's just give that some, give it a name that we can change. Let's give it some legs, and that's just going to be an array of things. And then let's also set, now we haven't included this yet. This is where I got the magic smoke. This is the PCA 9685 board. It's quite straightforward to get these working if you don't do silly things. This is where I'll put it. I'm going to put it in brackets for now because we haven't actually created this code. So PCA 9685 equals PCA 9685. I'm just going to comment that out for now because we haven't actually created that code properly. That'll be next week, I guess. And then we just need an init function. And in here, we can just set some default values. Now last week I said, oh, you can use your getter and setters in your init function, and somebody pointed out, let me just find, I did make a note of this one. So Jiv said you can't actually access your getters and setters from inside your initiation, and the reason that you can't do that is because it hasn't got to that part. Python executes, it interprets the code line by line, so if it hasn't actually read all that in, it doesn't even know they exist yet. So that's why we can't use the getters and setters at that point. Okay, so let's just very quickly do this. So we're going to have a back left leg. Well, we know it's a leg, and a leg contains the sort of shoulder part and the foot part. So leg is, we're going to give it a name, we're going to call this back left. We're going to give it a shoulder pin. Oops. And we're going to call that, remember we created that class at the very beginning called limbs, and whatever we set in there to be the back left leg, that's got a value in it. So whatever we set in there, and that means we can interactively change our pin numbers without having to go through our hard-coded code. So then that one is limbs dot, and this one is the back left foot. So that's that one. So we just need to do 4 of them, 1 for each of the legs. So should we just grab that and then just do back right, back right, back right, and then back right. And then we can grab both of them and we can do front. So this is front, that's front, that's front, that's front, and then finally those 2 are front as well. And then all we then need to do, let's put that back where it needs to be, is self.legs, which is the name of our array, and we just need to append to that these things that we've just created, which is the front left. Let's grab, that should be front right. Then we want back left. And then we want back right. Okay. And then at the very end, we just want to say print PicoCat is online. Or actually, not PicoCat, because we might have a different name. So let's just end that there. And let's just pass in the name. So self.name is online. Okay, and so that's the initialization function, and then let's have one last function in here, which is stand. And we'll say for servo in self.legs, servo.stand. Okay, we can just hide all this code that we created last week. That was just to sort of test out things. Okay, so that is pretty much our cat. So at the very bottom, let's just create a cat. So cat equals PicoCat, cat.stand. That will run all the code that we created. Now, what's the chances that I've created all that code flawlessly and it will work first time? So all we need to do to run this code, our Pico is connected down here. We just click run. If it can't access things, it will complain about them. So we can see here, it's saying it can't find the module PCA9685. So if we go back up to the very top here, it can't find that. So I'm just going to hide that for now. Don't worry about that. We didn't create that this week. We'll come back to that one. So let's just try that again. So run. So leg has no attribute name. So let's just have a look at leg class and see what the problem is there. So leg, so it's underscore underscore. So what we need to do there is just create property. It'll take us 2 seconds to do that. So let's do property and def name, and that's going to be self, and then we're just going to return self dot name, and then let's have another property which is name dot setter, and then let's just do name self value, and then we are going to say self dot name equals name. Okay, let's try that again. There we go. So you can see there, it's doing stuff. Now that doesn't look quite right because it's getting to 91 and it's not stopping. So there's clearly a bit of a bug somewhere in that code. We're a little bit out of time to go through and try and troubleshoot that. But I can guarantee that will either be because we've not got some error checking in there, or we haven't got some, there's probably a line of code that's missing. So let me show you the working version. So OpenCat is my actual working code, the one that we're working our way through PicoCat. I will go through that and I will find that error and let you know what that is. But you can see this has got a lot more to it. There is down here an outline where we can open up and we can see all the different functions and properties of each of the classes. So you can see there we've got all these different ones. We've got all the getters and setters for each of them, and so on. So if you're interested, you can open up OpenCat and upload that and see if that works any better. And if you want to upload the code to the Pico, all we do is just click this upload button here, and what that will do, you can see that it's got 4 files that it's going to write: OpenCat transition.py _ transition.py, which is the version I created and hid, and then we've got PicoCat, and then it basically just disconnects, and then you just have to click the connect button, and then you've got all those things on there. So you could now go into something like Thonny and open that up, and it will work fine. You'll be able to see that code in Thonny, and if we click run, it'll try and run the OpenCat code. But I was playing about with that just before the show, so that's probably got a bug in it at the moment. But the version that's checked into GitHub on the repository, I will leave a link to the OpenCat, the PicoCat repository in the description. PicoCat. Cool. So I hope you're enjoying this series. If you want to know more about this, we do videos every single Sunday at 7 PM across all those different time zones there. So 7 PM Greenwich Mean Time. I'm based in the UK, and you can probably find yourself on there. So we have the Americas and Canada on the left. We have Europe, Pakistan, India, and a bit of Russia in the middle column, and we have Australia and some Russia on the right hand column there as well, and China. We also have a website. I say we. I have a website as well, smarsfan.com. I created it to host all the information about Smars robots, but I'm also expanding it to have information about OpenCats. So as I build out my new OpenCat, the green and the orange version, and also a bit of auto DIY as well, I'll be adding and trying out these bits of code. I've just found, there's my Pi Hut. There's another Pico from the Pi Hut. So I've got a few spares just in case. So check out the website. I'm always updating that and adding stuff to it as well. Somebody's saying there, great video. We had crashing lots. Says hi as well. And Samo says hi. Hi to everyone. Sorry about the video sort of crashed halfway through there. I'll edit out that with the magic of Final Cut Pro and upload that to YouTube, so there's just a single video at the end of this rather than 2 videos, which can get a bit confusing. But I know people have shown great interest in Pico, MicroPython and OpenCat. I'm not sure which one of those 3, or whether it's the combination of all those 3 that people are interested in, but the Pico is definitely the thing at the moment. Lots of people trying to get hold of Raspberry Pi Picos. There is definitely stock of them available. Hi Ivan, hope you're doing okay. You can get hold of them as sort of singular units at the moment. The only issue is these things cost about what, $3 or $4, and then it's about that same again to get them shipped individually. So once the stock gets out there and enough people have got them, and that these things are, you know, wildly available, you'll probably be able to buy 3 or 4, 5, 6, you know, in a go, and then the shipping cost comes down. But it's definitely worth having more than one, I would say, just in case you get the magic smoke thing happening. Rest in peace, my little thing. I'll have to bury that somewhere, perhaps. I'll just stick it to my monitor as a reminder not to just do things without thinking them through. So yeah, once again, I managed to destroy that entire... There's the sad music gone. Destroy the sad the Pico by putting too much current through it. Crazy. So that's that. Let me see if there's anything else I needed to talk to you guys about. So I mentioned about the getters and setters. We talked about the magic smoke. And what we'll be looking at next week is that PCA 9685 board. How do we plug all of those servos into a board such as this one? And then through the magic of MicroPython, we just have 2 cables that come out. I mean, they're still like a bit melted from where the too much current went through them. But yeah, through the magic of the I to C, I squared C, some people call it, basically just a clock and a data cable, we can plug that into our Pico, and we can set all of these different servos and have them orchestrated perfectly. And that'll be the fun bit, making the cat, you know, come to life. Tom says he can't wait to see the cat meowing. And well, I like the idea of that. So Samuel says make a key holder. That's a good idea. So when we were putting together this studio, we had 3 keys to the door, and I thought I need to have some kind of key fob to keep this on. And I thought, what should I have? You know, I'm a bit of a fan of 80s and 90s cartoons and TV shows from when I was a kid growing up, you know, Transformers. So this one I have, does anybody know what that is? I think there's a bit of a giveaway because it actually says it on it, but if I hold it about there, you can't quite read the writing that's on there. Anybody recognise that? Comments below. And Samuel says, thanks, another interesting one, looking forward to the next. Absolutely, yes. I'm really excited. I was really excited to show you this easing and how we can make the motors sort of move around and have all the transitions and stuff. Just with that small disaster of the thing burning out halfway through when I was trying to actually get the servos to physically work. It is Thundercats, well done, son. Absolutely, thunder. So yeah, I had a mini disaster of that. Then we had that mini disaster midstream as well, where it cut out. I literally had to reboot the Mac and then unplug an Ethernet cable and plug it into a different port just to try and get this whole thing working. But I'm using a Mac M1, so it's very, very quick. There's like no boot time at all. It's just instantly on. And I was like trying to figure out, is this an internet issue somewhere else, or is it just that under there? I might have to upgrade. It's a Netgear switch. It didn't cost a lot of money. Maybe I need to get a spare one just in case, because we don't want that happening again midstream. Cool. So I think that's everything I wanted to cover off. I don't think there's anything else that I was going to talk to you guys about. It was mainly just to go through those signs, all those different, you know, transitions, easing in types, and then how do we make that into code? How do we do a transition function for each of them? So if you check out the GitHub repository, I will put a link to that. Oops, that's not what we want. We want that. You can have a look. In fact, if I open up this transition code here, you can see, just open it up from the correct place. Transition.py, let's just hide that. You can see there all the different formulas for the different transition types. So I've already done all that work for you if you wanted to cut and paste that. And all this works in MicroPython on your Pico with your OpenCat. So you can see there, ease out, ease in, out. And the one that we used was that one just there, ease in sign. You can see that looks slightly different because I was trying stuff out. One of the cool things you can do in Thonny, I've not figured out how you can do this in VS Code yet, is you can have a monitor, so you can actually output, you can print a value that's changing over time and it'll graph it for you. So you can actually see that it's a, you know, a smooth kind of plotted chart. That'd be quite a cool thing to do in Thonny. And this all works in there as well, because it's all just the same thing. Cool. So hopefully that's a good show for you guys. I hope you've enjoyed that, and I'll try and work on the PCA 9685 board for next week so we can actually get the limbs moving about, and then we can look at things like, you know, how do we get the distance rangefinder thing working. We've done that enough times with the with both the Auto DIY, the quad, SMARS quad, and the SMARS regular wheeled version, that I think we could very easily create a ping routine to do that for us. And then we can look at adding some extra goodies in there like sound as well. One of the things I would like to try and do is add one of these SD card readers. Like we have, this is a Raspberry Pi Zero, but these card readers, memory card readers, oops, they're actually quite simple as how they work. It's a bit like calling something from I2C. You just sort of read from a memory address from the card and then just bring the data in, and you just need some function that can understand what a file system looks like on one of these cards, but they're actually quite straightforward as I understand it. So perhaps we could add that to our Pico, and we can read in files from a SD card, and then we could have like cat sounds that played back through a speaker or something like that. So I have got you know, piezo speakers and things like that we can add to it. This is quite a big one. But I've got a whole box full of smaller ones. And we did an episode on how to bring sound to the Arduino. So if you was interested in that, I will create a link to that as well. So that's the Sound Arduino Cool, just making a note of that so I can do the card thing later on. Cool, great. I think that's everything we're going to cover off today. Thanks for joining me. I shall see you all next week.